This is Pre-Calculus section 10.4 on hyperbolas. This is writing equations of hyperbolas, and this is the last several problems in your notes on hyperbolas. So it begins with writing the equation of the hyperbola having center 0, 0 and vertex 0, 1 and focus 0, 6. As we've done with all these other problems that say write the equation of the blank, we're going to start with a graph, because a graph can often tell you what kind of conic section it is. So we have a center of 0, 0, so we'll place the center on here, a focus of 0, 6 up here, and a vertex of 0, 1. So this was the focus, this was the vertex, and this was our center. Since all of these are piled up on the vertical axis, this tells me that this is a vertical hyperbola, because that tells me that we're looking at this equation, y squared over b squared minus x squared over a squared equals 1. Now remember, I always let a go with x and b go with y, so a is always my horizontal component and b is always my vertical. The reason we'll have y squared first here is because it is a vertical hyperbola, so y squared has to come first. Then I just need to find my a, b, and my c. Because we know that the center is 0, 0, and the vertex is just one unit up from there, and that is in a vertical distance, that tells me that b is 1. The distance from the focus down here to the center is c, and that happens to be 6. I can use my a squared plus b squared equals c squared to find out what a is. So this is a squared plus 1 equals 6 squared, which is 36. Subtract 1 from both sides. A squared is 35, or a is the square root of 35. So I'm going to put 1 in for b, so this is y squared over 1, minus x squared over the square root of 35 squared, which is 35, equals 1. Now MathLab does not want you to write this 1. I like the 1 because it just gives me the symmetry of a fraction minus a fraction, but they're going to rather that you not write the 1 in the denominator. Another set of information, we've got vertices at 0, 12, and 0, negative 12. Well, I don't have room on the graph to fit that in, so I'm just going to fake it up here. This is 0, 12, let's say, and another vertex down here at 0, negative 12. And we've got some information about the asymptote, but I won't worry about that just yet. The fact that my vertices are on the vertical axis, that tells me that this again is a vertical hyperbola. And I will figure out the center from this information. Your center has to be halfway between the two vertices. Well, the number that's right halfway between those two vertices is right there, 0, 0. That is the center. Since the center is 0, 0, I know that my format is y squared over b squared minus x squared over a squared equals 1. Since the center is 0, 0, I don't have to worry about an h and a k. I do need to find my a, b, and c. So I know from the graph here that the distance from the vertex down to the center is counted at a vertical distance, therefore that is b, which means b is 12. Now, I don't have a or c on my graph. This is where I have to go to the asymptote. The asymptote is y equals 3x. That means you're looking at the slope being 3, or 3 over 1 if you want, and your asymptote is b over a. So if you solve this equation, knowing that b is 12, you have 3 over 1 equals 12 over a. Cross multiply, you have 12 equals 3a, therefore a is 4. And it turns out I don't need c. I need to be able to find a or b to go into these positions right here. So that will be y squared over b squared, which is 144, minus x squared over a squared, which is 16, equals 1. Now we have a different center. We have a center of 2, negative 3, so this makes this just a teeny bit more complicated, but we'll start with the graph. We have a center at 2, negative 3. There's my center. Focus of 8, negative 3, 3, 4, 5, 6, 7, going off the graph a little bit, negative 3. And a now let's identify that as a focus. And a vertex of 5, negative 3, 1, 2, 3, 4, 5, negative 3. Because these are all lined up horizontally, this tells me that this is a horizontal hyperbola. And because I have a center that's not 0, 0, I know I'm looking at x minus h quantity squared over a squared minus y minus k quantity squared over b squared equals 1. And I could have gone directly to putting in my 2 and my negative 3 rather than using the h and the k, but I wanted you to see the format right there. So we've got h is 2, so I'll just superimpose a 2 over here. K is negative 3, which is going to turn this into plus 3. So I've got the top part. I just have to work on finding A, B, and perhaps C. So I have a center right here. This was a vertex of 5, negative 3. So the distance from this point over to this point, you can just count 1, 2, 3. That's in a horizontal distance. Therefore, A is 3. Find C, we can count, but be careful. Remember, I went off the graph a little bit over here, so it might be better to look at the fact that we're going from 2 out to 8, which is a distance of 6. On the graph, it looks like it's a distance of 5, but it's just because I went off the graph and we had to estimate. So the distance from 2 over to 8 is 6, and that is the C value. We will use a squared plus b squared equals c squared to find out what b is. 3 squared is 9, b squared, c squared is 36, solve, subtract 9 from both sides is 27. And incidentally, every one of these I keep going and solving for actually a and b and perhaps c, but I don't really need to do that. What I'm looking for is b squared. B squared is 27, so I can just put a 27 in that position. So I have x minus 2 quantity squared minus y plus 3 quantity squared. And b squared is already 27, so I didn't need to really simplify that at all. And come back here, since I do know that a is 3, I might as well say 3 squared gives me 9. So that gives me the whole equation of this hyperbola. One more of these, we have a focus at 3, 6. So over 1, 2, 3, up 1, 2, 3, 4, 5, 6. And another focus at 7, 6. Let's label this. That's a focus. 4, 5, 6, 7, 6. Both of those are foci. And we have vertex 6, 6. 1, 2, 3, 4, 5, 6, 6. So since everything is piling up in a horizontal fashion, I know this is a horizontal hyperbola. Also, I know that my center has to be halfway between these two foci. So we can look at the graph and count, or we can do the midpoint between 3 and 7, which would be 3 plus 7 is 10, divided by 2 is 5, of course, comma 6, and that is my center. We have decided that it is a horizontal hyperbola with a center at 5, 6, so I can go directly to this, save myself a little bit of writing, over a squared minus y minus 6 quantity squared over b squared equals 1. And all that's left is for me to figure out what these distances are. Now, we do know the center is 5, 6, so I can put that on here now. That's my center of 5, 6. The distance from the center out to the vertex is 1, and that is being counted in a horizontal fashion, so I know that A is 1. The other thing I know is that the distance from the center out to the foci, to one of the foci, is 2. Whether I count it in this direction or that direction, it's a distance of 2. That means C is 2. So I can use a squared plus b squared equals c squared. 1 squared is 1 plus b squared. 2 squared is 4. Subtract, and we've got that b squared is 3. Same thing I said a minute ago, I don't really need to go to b equals the square root of 3, because I'm going to have to square that for my denominator. So we will have x minus 5 squared over a squared. A happens to be 1. 1 squared is 1. Minus y minus 6 squared. B squared is 3, so I can just put the 3 right here. And of course, equals 1.